Your screen is visible?
Yes, sir.
Okay, fine. In today's class, let us have a discussion on the four informal design guidelines for relational databases. Whenever you plan for a designing of a table, okay, you must follow these four guidelines. It is not compulsory, but if you don't follow, then what will happen? Okay, we're going to see in the consequence slides. There are four informal guidelines. Informal means you can follow or you may follow or you may not follow. But if you follow, it is good. If you don't follow, then what kind of problems you will going to face? Okay, that we will going to see it today, and particular things like semantics of the relational attributes. For there is one guideline that also we're going to discuss. First, we're going to discuss what exactly it is semantics of the relation attributes. Then we'll give the guidelines for that. Second, redundant information in tuples. So redundant means duplicate values. Duplicate values. Same repeated information. Repeated information in the tuples. Tuples means rows. Okay, and update anomalies. So first we'll go to what are the problems, then we'll give you guidelines for that also. Then null values in the tuple. Sometimes we enter some, what do you call, what is your, yeah, in spite of in a middle initial name. Okay, some of you will go to keep it blank. In date of birth, you will keep it blank. You will mention it as a null. Okay, in other attributes, okay, percentage, you will keep it null. In phone number, you will keep it null. Means, okay, it also creates some problems. There are various reasons to put the null value. Okay, those things we are going to discuss, and we are going to give the guideline. What is the guideline for that? Okay, to avoid this. Okay, that also we are going to discuss. Then spurious tuples. Spurious tuples means here unwanted information. Unwanted information. It should not be there in the table. It should not be there in the table. Got it? So we have to remove such kind of things. Whenever you join multiple tables, you should not create, or you should not take unwanted information has to be generated. So such unwanted information is called as spurious tuples. Got it? So for these four things, issues, okay, we'll have a design guidelines. Got it? We're going to see one by one. What is the first one? Which is the first issue? Semantics of the relation attributes. Second one is redundant information in the tuples and update anomalies. Third one is null values in the tuples. Fourth one is spurious tuples. We'll look at first one. Informal design guidelines for relational databases. So why we need to go for this? What is relational database design? Relational database design means grouping of attributes. Form a good relation schema. Form a good relation schema. What is that good relation schema? That we will going to discuss. Okay. So which are all the attributes which are necessary? We will going to group them and we form a design for the table. There are two levels of relation schemas. One is logical user view level, logical level, and another one is storage level. Okay, so that we have studied in conceptual and logical and physical. Okay, so there are different types of levels of schemas: conceptual schema or logical schema, or then storage, physical schemas. Design is concerned mainly with the base relation. Yes, design is concerned only with the base relation. Base relation means, okay, whenever you design the table, what are the criteria for good base relation? What are the criteria for creating of good table? Okay, good relation. Okay, we'll have a discussion on that. Okay, if the table is, or if the relation is not good, if you have created a table or a relation, if it is not, if it is also a table, but how can you measure it whether it is a good design or bad design? Got it? So we'll have a discussion on that. First one, semantics of the relation attributes. Semantics of the relation attributes. See here now, this is the guideline. This complete slide is there. No, it is a guideline for the first one. The meaning is that design a relation schema so that it is easy to explain its meaning. You design the table, you design the relation in such a way that it should be easily explained. It should be easily explained its meaning. As we discussed in the previous slides, or a company database, employee table. What is that employee table? We have discussed, right? Every employee will be having the employee number, that is SSN number, and name, middle name, last name, then date of birth, sex, then department in which he is working, and who is the supervisor for that. Okay, all these information. So easily I can explain that table, right? If you take another table, department table, how can I explain? Every department will be having the number, department number, and every department will be having the name. Then it will be having, what is that? Supervisor SSN, and his or her start date. So this is how easily I can explain that table schema. So design a relation schema so that it is easily explained its meaning. That is required. That is the first thing. Do not combine the attributes of the multiple entity types and relationship types into single relation. Yes, this is very important. We have seen. So first it should be designed in such a way that it can be easily explained its meaning. Next thing is, do not combine the attributes of multiple entity types. Means, see here now. Now I'll go to combine employee table and the department table. So employee will be having, let me write, can I write it here? So this is for SSN, this is for first name, middle name, and last name of an employee. Then sex of an employee, then date of birth of an employee, then supervisor SSN, then what is that? Department number and department name, and what is that? Manager SSN, then one more, start date and supervisor SSN. See here now, assume that it is a department number, its name, then manager SSN, It is a manager SSN and start date. Start date. Start date. Got it. Here it is SSN, first name, middle name, and last name, sex. Then what is that? Next is supervisor SSN, date of birth. Then what is there? Next, what is there? Is there any other attribute? Okay, assume that it is another attribute. See here now, actually only this much is employee table. This is up to here, it is a employee table. This, in that employee table only department number is there. Okay, in department table, here it is, from here to here it is a department table. In that table, department number, okay, name, manager, then manager SSN and start date. So only combined thing is only this much, department number. It is there in this table and this is the table. Why? Because in department table it is a primary key. Here it is a foreign key in the employee table. In spite of having two tables, now I am going to make it as a single table. If you combine these tables, two tables, what happens? If you combine these two tables, okay, employee table and this. See here now, first employee, his name is this, middle name is this, so and so. He is working in department number 1 and department name is this, manager is this, then start date is this. Okay, if you follow this way of creating the tables, designing the tables, what will going to happen? Please tell me, any one of you. What is the difference between this and that? Okay, having separate two tables or combining employee table as well as department table into single table. All the attributes of this employee department I am going to create. What happens?
Sir, we can easily access the data, sir.
Where?
If we combine two tables,
If you combine two tables, okay, easily you can access the
data.
Okay. Then next. Ria. Please pardon.
Easily access, sir.
Easily. So, is there any problem if you combine those two? What are the drawbacks?
Storage, sir.
Storage, exactly. Then what happens? Soumya. If you combine those two tables, what happens?
Sir, entities are repeated, sir.
What happened?
Normal, same entities are, sir.
Same entities, which way? Okay, see, let me explain. Good. Meaning is there. See, what is this? Do not combine attributes of a multiple entity types. It means if a relation schema corresponds to one entity type like a employee or relationship type, it is straightforward to explain its meaning. See here now, only I am discussing about the employee. If employee table is separate, then I can easily explain its meaning. What is employee means? Employee details. I don't want the department details, only in which department he is working. Why should I take his manager and his start date? It is irrelevant, right? In employee table, okay, in which in which department he is working, only that information is enough. In spite of that, when it was started, when he had joined his manager, okay, all those things, why do we need those things? How many employees are working in that department? It is not related, right? So if you take employee table, if you take department table, only I can explain it easily. Okay, department number, this is the name of the department and he is the manager and he has taken the charge on so and so date. In spite of that, he is also working in that department, he is also working in that department. If you want to try to explain one department, if there are 100 employees are working in that, so you need to explain all the 100 times. Write it. So this is what the semantics of the relation means, which are related attributes. Only you take those things, meaningful attributes. Just you need department number. Okay, if you see particular employee, John Smith, he is working in department number 5. If you want more information regarding that department, again you link that department number. Okay, and go to that department number and see which department, who is the manager and when he has started managing. Got it? If it is required. In the department table, department number, department name, manager, SSN and start date. If you need his manager's information in detail, go through that SSN number and link with the employee table, and here you will get a complete information about him. Okay, what is his first name, last name, middle name, gender, etc. All those things. Got it? So this is how. So make a separate table. Okay, meaningful group of attributes which gives a meaning for the relation, and it should be explained easily. It should be explained easily. Otherwise, if the relation corresponds to a mixture of multiple entities and relationship, semantic ambiguities will result. Means ambiguity confusions will result and a relation cannot be easily explained. This is the first guideline. How you need to design the table. This is the first design. What is that? It should be, the schema should be, relation schema should be easy to explain its meaning. Do not combine the attributes of the multiple entity types. Got it? If you combined, okay, ambiguity will start and you will get, what is that? Confusion while explaining its meaning of the table. That is the first guideline. Is that first guideline is understood, all of you?
Yes, sir.
Okay, now see here now. Here, employee department. Assume that we combined here in a employee table. So we have taken only few attributes here. Employee name, his SSN, birth date and address from the employee table. Okay, and here in this same department number, department name and manager SSN, these are the attributes of the department. When you combine these things to form a table, okay, so it forms ambiguity, and as Ria told, okay, and Soma told, what is that? So duplicate values will be stored, unnecessary information is stored again and again. When you store the unnecessary information, okay, so probably it is necessary, but we are storing it again and again. Why we need to store the department name and manager SSN again and again? Got it? So it consumes a space, more memory. Got it? This is one example. Another example here, employee and project table. When you combine these two, here SSN number and project number, R's, E name, P location, project name, and this project number, okay, R's. These are from the project table, and SSN number and E name are from the employee table. Okay, so here we are combining, actually hours and project numbers are from this hours, and project name or project number are from another this thing. Got it? When you combine that thing, so again it creates a problem. See here now, let us take here it is explanation is difficult part. Now same employee department table can be, if you have a table employee where SSN is a primary key and department number is a foreign key. Why it is a foreign key? Because here it is a primary key. Here manager SSN is a foreign key and it is primary key here. This is how you can combine these two. If you want to know the information of the manager, if you need his information in detail, then you just through this manager SSN you can go to SSN, okay, then there you will get his name, date of birth, address, department number in which he is working. If you need any department information, like particular employee is working in the department number 5, then directly it is a foreign key, so just you go to its primary key, then you will get the details of that department easily. Department name you will get, department number you will get, and manager SSN you will get. Got it? This is how easily you can do it. Here this, see here now, 3 tables are combined, attributes of the 3 tables are combined. Here in the from the department location, department number, department location, project name, project number, P location, department number, then works on SSN, P number, R's, all these 3 tables attributes are combined. So it is very difficult to explain it. In spite of that, you can have a primary key and foreign key. Using those, you can link the relations, these schemas, to get more meaningful information. Got it? See here now. These are the examples of relational, what is that? Semantics of the relation attributes. Is it clear now? First guideline. Understood?
Sir. Yes, sir.
Yes. Now, second one is redundant information in tuples and update anomalies. Anomalies means In Kannada it is called as Vaparityagalu. Vaparitya means what do you call it as? What is the meaning of that? Kannada Vaparitya. It is not as usual. It is not as usual. Got it? So it will be having some problem. Got it? Now, redundant means duplicate. Again and again, same information. Got it? Redundant information in tuples and update anomalies. See here now. Information is stored redundantly. What happens here? The same information, same employee information is stored again and again, again and again, again and again. Due to this, there is a wastage of space. Why we need to have a same employee information again and again? It is not necessary, right? It is a waste of space, waste of time, waste of money, etc. Got it? And it causes the problems with update anomalies. It causes the problem in insertion, it causes the problems in deletion, it causes the problems in while modification. When you are storing the information and again, what happens? It creates the problem at the time of inserting a value or a tuple, or deleting a value or deleting the tuple, or while doing the modification of a tuple or any value of the attribute. Got it? When the information is stored redundantly again and again, these are the problems it causes. Now we'll see what problems it will going to cause. In the previous example, see here now, here we combined employee table as well as department table. This is an employee table and department table. Got it? Let me take example of the same. Here employee name will be there. Employee name, his SSN, birth date and address. We have a department number, department name and manager SSN. See here now, wastage of space as we discussed. Let me explain what is that wastage of space. Now, see here now, John's first one, let me give a number for this, 1, 2, 3, 4, 5, 6, 7 and last one is 8. So employee 1, his SSN is this, birth date is this and address is this, and he is working in department number 5. It is more than enough. If you need his department information, you can directly go for the department table. But you have combined the attributes of the two tables. Then you are entering research department, its name and who is the manager of that. Again, employee 2, Franklin, he is also working in the same department, department number 5, and what is the name of that table? Research, and manager SSN is this. See here now, here the which one? 5th employee, he is also working in the research department, and 6th employee is also working in the research department. We are entering again these information again and again. See how many times we entered. 1, 2, 3, 4. Same information we entered, okay, in the table 4 times. 4 times same information is entered in that table. See how much of wastage of space here. Hmm? In spite of just one department information I am telling you now. Okay, one information. If you take a fourth, which is that department number 4, administration, here also it is there, here also there, and there. Okay, again see here 3 times, 1, 2 and 3. So there are 3. What is that? Department 4 number information. Department 4's information is 3 times explained, and there is only one employee who is working in department number 1. Okay, no problem, but his information is also department name, and this thing is entered. Okay, so see here now. Here it is a name, here it is a manager SSN. Manager SSN. Assume that it takes, for you want to store name, assume that it takes 10 bytes. Assume 10 bytes of memory. For storing the manager SSN, again it is also takes 10 bytes. 10 bytes of this thing. Assume. Here what happens? 1, 2, 3, 4, 5, 6, 7, 8. 8 into 10 for, what is this? Name. So 8 into 10 is how much? 80 bytes. 80 bytes you required for what? To store the name here. And similarly 8 into 10 bytes for this manager SSN. Again you need 80 bytes. Again you need 80 bytes. So total how much is you required? 160 bytes of memory you required to store these information in this employee department table. Got it? If you have separated these two tables, what happens? How many tables are there? How many departments are there? 3 departments. Okay, so you will be having 3 departments. One headquarter, then administration, and another one is research. Here you need this. Here I did not consider the department number here. Okay, here I did not consider the department number here. See, assume that here it takes 10 bytes for this and 10 bytes for this. 10 into 3, 30. Okay, and 10 into 3, it is 30. So 30 plus 30, it is 60 bytes. In 60 bytes, you will get the clear information. We are not storing the same information again and again. But here, just when we have only 8 employees, we are getting this much of memory, wastage of memory. Assume that if there are 100 such tuples, 100 tuples are there, 100 into 10, 1000, this is also 1000, 1000 into 1000, 2000. Okay, 2000 bytes of information is repeatedly we are entering here. But here, what happens? Only 3 times, only this is fixed, 60. Here it is just 60 bytes, here it is 2k bytes when we have 100 employees. When you have 100 employees, see, that is the difference. Got it? So this is 1. Similarly for the employee and project department, same information is repeating. Okay, let me take this employee department example only. Got it? Is it understood now? Is that the example what I have explained? Is it clear?
Yes, sir.
Okay, fine. Now, see, here as I told, here it causes the problems with update anomalies, means while inserting while deleting, while modification. How it will go to create the problem? Okay, while inserting, deleting and modification, we will see it now. Update anomalies. Consider the relation employee project. Here employee number and project number and E name, P name, project name, then number of hours he worked for a particular project. Changing the name of the project number here, because this is having the project number. Where is that project number? Okay, if you want to change the project number from the billing to customer accounting, see here now, project number what I want to do here project number is there, no? Here project number is there, no? Project number is so and so project. Okay, project number is, assume that this product X. I want to change this to another project name. Okay, what happens to customer accounting may cause this update to be made for all 100 employees working on the project 1. See here now, if you want to do any changes with this particular project number 1, I want to, actually it is project number 1 is product X. Product X is the project name of that project, whose number is 1. If I want to change its name here, so if there are 100 tuples, I need to make changes in all the 100 values. I'll take an example of the same table here. I'll take the better, this is, you are comfortable with this now. Here I want to change research department name into, what is that, another account section. I'm going to change it as a research to account. Okay, I am changing the name of the department from research to account. See, if you are having the separate department table, just you can, what you can do, just you go to particular department number 5, just there you change that table name or name of the department as an account department instead of research department. Wherever that research department number 5 is there, no, automatically it will get updated if you have a separate table. When you combine these, okay, what we need to do, whenever you want to make a changes, here also you need to make it account, here also you need to changes to research to account, here also you need to changes to account and account. These many times you need to do. If there are 100 employees, among them 50 employees are working in research department, then 50 times you need to change research to account, like this 50 times. Here only one time it is enough, because here also it is department number 5 is there, here also it is department number 5 is there, just it will going to link it to this, then you can get the information of that department. Similarly, for if you want to change the administration manager will be keep on changing. Got it? When manager keeps on changing, so here just you need to change the manager SSN in the department table only one time. So wherever that administration block is there, no, that department number 4 is there, automatically it will get updated if the separate department table is there. Otherwise, here you need to change how many times that manager who is working in that department number 4, you need to change it manually those many times. This is the problem while updating the table or value of a tuple. Is it clear now? Is it clear?
Yes, sir.
Okay.
Yes,
Now,
sir.
example of insert anomaly. Cannot insert a project unless a employee is assigned to it. See here now, one more thing. I'll take an example of the department. Now, here in this, assume that we have a department now. We have a department. So some of the employees are working there. Still, we have not assigned any manager. Still, we have not assigned any manager for that department. So, department is there. Department number 5 is there, department number 3 is there, department number 4 is there. If you have a separate table, okay, so here department name is there, department number is there, and manager SSN we need to enter. Still, that manager is not assigned. Got it? So, in such cases, okay, here just you mentioned in the employee table, you just mention the department number, more than enough. Got it? Later you can assign the manager. So, if you have a manager, this thing, here in the combined table, what happens? If you don't have a manager SSN, because manager is not yet assigned, then this inserting a tuple also, new value of a new employee also, it is very difficult because you need the manager SSN, otherwise you will going to keep it as a null. Got it? This is one thing. Another thing is, now see, manager SSN is there, manager is there, okay, so you have taken the employee, but you have not assigned any department. You have not assigned any department to him. Then also it is problem. So it creates the problem while inserting the values. So cannot insert an employee unless he or she is assigned to a project. Means, so here in this, employee must have a project. So if that project, if you have a combined table, then see, it is not compulsory that he must work for a project. So project will get later, but we'll have an employee first. Then sometimes project will be there, we're going to hire an employee later. So in such cases, when employee is there, you have to have a project, or when you have a project, then you must have an employee for that. So if any one of them is not there, then inserting a value into the table, it creates the problem. Got it? This is the anomaly. It creates the problem while inserting. It is called as insertion anomaly. Then examples of deletion anomaly. See here now. Here. Now I want to delete which department? Department number 5. I want to delete department number 5 from that research department is no longer exist henceforth. I want to delete that research department. Okay, wherever that research department is there, no, just if you have a separate table, just by deleting that one tuple, it is more than enough. Here you need to delete all the tuples wherever that department number 5, this tuple also you need to delete, this tuple also you need to delete, okay, and this and this, all these tuples needs to be deleted. So while deleting, see here now, all the 4 values, so 4 values, 4 tuples, department number, department name, manager SSN, all these 4 tuples will be having the blank. So what about these employees? In which department they are working now? It creates the problem. Or if you want to delete a particular employee who is working in department number 4, he is a Jennifer. Okay, this lady Jennifer, I want to delete her information who is working in department number 4. See, again you need to delete this information also. Again here also, wherever that Jennifer is there, no, in the project, this thing, and along with her project, everything needs to be deleted. How many times it is there in the table? Got it? So again here also it creates the problem while deleting a value in the table, a tuple in the table. Got it? This is anomalies, where it is simple employee, where we, yeah, deletion. Okay, see here now. Example. This we have seen it now. Got it? This is for the same this thing. Simple statistics for the employee, project employee, and this thing. Again, when you combine it, so joining, so natural join, inner join, outer join, all such kind of joins are there. Okay, that we will going to see it in relational algebra. Okay, so it is a mathematics algebra which we apply for relations, means tables, such thing that we will going to discuss while discussing the relational algebra. What are the different types of joins and all those things. Got it? That time I am going to discuss in detail about those. So when we combine these things, again same table it is there. Got it? Now for these kind of things, redundant information in tuples, so and update anomalies, what is the guideline? You have seen the problem now. Now check it. What is that? Guideline for that. Guideline for that. Design the base relation schema so that no insertion, deletion or modification anomalies are present in the relation. See here now. You have to design the table, you have to design the relation schema in such a way that schema should not have a insertion, deletion and modification anomalies that are present in that relation. Clear? So like this you have to design the schema, relation schema. If any anomalies are present, any insertion, deletion or update anomalies are present, note them clearly and make sure that the programs that update the database will operate correctly. So if at all it is present, okay, if at all it is necessary, then while doing the programs, you check it clearly, note down it and check it clearly whether it is creating any of the problem or not in the databases. Got it? This is the guideline, second guideline. Is that second guideline is understood? Anomalies and the second guideline.
Yes,
Right.
sir.
Okay, fine. Third one is null values in the tuples. Null values in tuples. As far as possible, what is the guideline number 3? As far as possible, avoid placing the attributes in a base relation. Avoid placing a attribute in a base relation whose values may be frequently be null. Wherever it is, while inserting the values for particular values, a tuple, try to avoid null values as far as possible. Sometimes it is, we are forced to enter the null values, but we have to try to avoid such null values as far as possible. If nulls are unavoidable, if null values are unavoidable, make sure that they apply in exceptional cases only. These must be applied. Enter the null value only when it is an exceptional case. We don't have any other choice to enter apart from the null value, and do not apply to a majority of the tuples. So whenever you have a chance, then don't enter null, as I told in the beginning. Okay, mobile number null, you will keep it blank. Age, you will keep it blank. Percentage, you keep it blank. Only which are the star marks are there, like your SSN number, your name, then you will going to enter. Rest of the things are kept blank. So you have to try to avoid such blanks. Got it? It is not good way of designing the relations and entering the values for a tuples. Got it? So why we are entering the null values? What are the reasons for that? The first reason is attribute is not applicable or invalid. See here now, for a student database, student table, if that table is having the salary, so you are forced to enter null values, right? Whenever what is the salary of you, so you will go to enter null, because it is not applicable for you. Salary field is not applicable for you. That time you will go to enter null value, right? This is the one reason. Second reason is attribute value unknown, may not exist. May exist, it is there, but you don't know. The value is there, the attribute value is there, but it is existing, but right now you don't know about that. Right now you don't know about that. Example, you are entering percentage of SSLC. You have the SSLC percentage. You have SSLC percentage, but you don't want to disclose it. You don't want to disclose it, or you don't want to enter it, or you do. You right now you don't know exact percentage or exact mark, total marks scored in the SSLC or total marks scored in the PUC. But it is there in your marks card. It is exist, but right now you don't know. Right now you don't know. So that is the second reason, which is that attribute value is unknown. It is not known, but it is exist. Got it? And third reason is the value, you know it. It exists. You know the value, but you don't want to unavailable. Means you don't want to express it, or you don't want to bring it to the others notice, or you don't want to enter. Example, your date of birth or your mobile number. Whenever it asks the mobile number, what we do? Sometimes we know what is my mobile number. Okay, I know what is my mobile number, but I don't want to give it. I don't want to enter it. Probably it may ask in Facebook and all those things. So there we hide it, or purposefully we will not going to enter that value. Got it? See, these are the three reasons. What are those? Attribute is not applicable. Example, student will not be having the salary. Salary is not applicable for you. Second one is, you know the value. Value exists, but right now you don't know about it. Got it? Example, total marks scored in the PUC. Okay, you have appeared for the PUC, then you have passed PUC, and you taken the admission for degree or post graduation, but right now you don't know that total marks. That's why you are going to keep it as a null. Got it? That is the second reason. Means It is unknown, but it is exist. Third one is it exists, you know, but you don't want to reveal it. You don't want to give it. Purposefully, you will going to enter it as a null. Got it? Like your phone numbers. Got it? These are the three reasons for null values in the tuples. Is it understood? Understood? All of you?
Yes, sir.
Yes. Last
Yes,
one.
sir.
Yeah, last one. 2 minutes. I'll finish it off. Spurious tuples. Bad design for a relation database may result in erroneous results for a certain join operation. Okay, certain join operations, as I discussed. Okay, there are different types of join: natural join, outer join, inner join. Okay, like this, whenever you do perform join operations, it creates, what is that? Spurious tuples. Spurious tuples means same information is repeated again and again, which is unwanted. Got it? Which is meaningless. That is called as spurious tuples. Okay. Then, see, this is an example. You have a employee location, employee name and a employee location. If you make these two as a primary key, and if you make employee project, this is one table, this is another table now. Okay, here in this, these two are the primary keys, and here SSN number and the project numbers are the primary key. When you apply the natural join, when you apply the join condition, what happens? It creates a spurious tuples. It creates, assume that these two are the tuples now. These are the tuples for, these are the values for entity set for this table. Okay, these are the tuple values for this table. Got it? When you apply join condition for these two, when you join these two tables, when you join these two tables, what happens? See here now, unwanted information is again and again it will go to display. See here now, example, if you take this 1 2 3 4 5 6 7 8 9, the project number 1 is this, 32 hours, product X this, and his name is this. Again here same, he is working in only project number 2, and this product Y, again this and this. Same information, much of the things are repeated again and again, only project number is changing and product name is changing, project name is changing. Got it? If you have proper planning for this thing, okay, so you will get this. Then what is the guideline? Fourth guideline, design relation schemas so that they can be joined with the equality conditions. Okay, what is that equal join and all those things, condition that we'll go to discuss while discussing the algebra, relational algebra. Got it? That are appropriately related. Like you take the proper primary key and foreign keys, which makes a pair in a way that guarantees no spurious tuples are generated. No spurious tuples are generated. Better you take a proper foreign key and primary keys. You make them combined. You apply the equality condition. Then you will get a proper. It will not going to generate a spurious tuples. Got it? Avoid relations that contains matching attributes that are not, which are not a primary key and a foreign keys. Okay, so these will produces a spurious tuples. Example here, this e name is not a primary key. Okay, battery is down. Okay, yes, and here project number and this, which are primary key and foreign key, you try to combine them properly. Here also, instead of this employee name, if you would have taken the employee SSN number, then you would have combined these two, then it avoids the spurious tuples. Okay, so these are the four guidelines. These are the four guidelines which are there you have to follow while designing the schemas. These are informal guidelines. Informal, it is, these are not compulsory. These are not compulsory. So but you have to follow these things. What it? So next class we are going to discuss about which are formal, like dependencies, what are the normal forms. Okay, all those things in the next class. Actually I wanted to complete the entire thing in this, but it is lot of thing is there, so I may require another 2 class. So Monday and Tuesday